All right, the first thing we are going to do today, since we have just finished the unit 5, I wanted to quickly go over our Think Central. Guys, I'm going to ask for whole body listening so that I can hear myself think. Don't worry about the supplies yet, because we're going to go over our quiz from Friday. How many of you felt that you could have done better or you wished you would have done better? Yeah, I know it was a tough one. I've been teaching this curriculum a long time. You're not the only ones. It is every year. It's a struggle. It's a tough one. The good news is we will be talking about two-step word problems for a long time. So it's not like if you didn't master it today, that you'll never see it again or get that opportunity. You will. I'll be putting problems like these in our review, not probably this first week because we have a lot of new vocabulary and concepts to learn, but throughout the rest of the school year, you won't forget about it. It'll still be part of our learning. But I wanted to quickly go over it with you. So in your math spiral, you're going to write what I write. So put your scissors down on the count of 3. Put a pencil in your hand. 1, 2, 3. Pencil in your hand and your math spiral ready. There we go. All right. So I'm going to read these to you. I'm going to show you how they expected you to answer these because sometimes it's just the format that gets in the way. Lila makes bags of stickers that are exactly the same for 5 friends. She uses a total of 70 stickers. Each bag has 2 butterfly stickers and the rest are flower stickers. So you know we're doing two-step word problems. The first step is that you know there's exactly the same for 5 friends, these bags of stickers. And she uses 70 stickers. Each bag has 2 butterfly stickers and the rest are flower stickers. So if I'm thinking, if she's making bags for 5 friends, I'm thinking of bags, right? Here they are. Here's her friends' bags and they have stickers in them. She uses 70. Why would they do that? Right, because it's a huge number. Okay. I could count, or I could see how many 5s are in 70. What are you thinking, Ellie? Oh, thank you, honey. So I have to figure out how I would divide 70 into 5 into 70. So I could do this. 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and I'm going to run out of room. 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, are you kidding? 40, I can't believe I did that. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. Oh my gosh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 stickers in each. So they're each going to get 14, but 2 of them are butterfly stickers and the rest are flower stickers. So I would have to take 2 away and find out that there was 12. Now here's what you had to do. Because I had taught you how to divide in big numbers like that, you had to draw a picture. And it took time. So you would have put, there are 14. And I can't actually get it. There it goes. What can I do for you? 14. It's at the back table. 14 stickers in each bag. How many flower stickers? And then what does this say?
That's the Bobcat one.
Oh, then, let's see.
I'll find it. Don't worry. You do your thing. I got this.
There are 12 flower stickers in each bag, okay? So that's what you would have done. That was tricky because that's a number you're not used to dividing into, so that makes it difficult. But you do know how to draw a picture, and it's time consuming, but it is possible. Now this was like the one we did about Gabe with his GoPro. Troy saves money for a bike that costs $127. He saves $59 one month and $41 the next month. How much more money does Troy need to buy the bike? Well, you should have added the 59 he saved one month and the 41. It's not the only way to solve it. You could have subtracted twice. Some of you like to do that. 9 plus 1 is 10. 5 plus 1 is 6. And 4, you would have had $100. You would have subtracted from the total of the bike and figured out that you needed $27. So was $60 reasonable? No, you should have written here. No, the answer is not reasonable. Troy needs $27 more to buy the bike. Okay, so 2 steps every time. You have to figure one thing out before you can solve the second problem or answer the question. All right, this one was pretty simple. I think most of you got this one right. This one was like the bus. We talked about this. We said ours was a train. We used those keywords, get on, get off. The downtown bus had 13 passengers. When it stops, 5 people get off. So we subtract and get 8. 6 people get on. Get on means to add. So you should have gotten 14 on the bus. How many of you think you got that one right? Now the numbers are different. It changes every time. So you don't always have the same numbers. So it would have been something similar to that. 14, and then this is your unit, passengers. All right, number 4, Lauren has 109 coins. She sells, that's your keyword, 53 coins. She wants to put the rest of the coins in an album. Each page in the album holds 8 coins. 2 steps. The first one, you're using that keyword sells. What should we do? Microphone answer. Subtract. So you should have taken 109 and gotten rid of 53 because she sold them. That's your key word. 9 minus 3 is 6. And I'm just going to look at this as 10. You could do this, or you could just think of this 10 minus 5 is 5. Now, I know she's going to divide because it says she wants to put them in an album, and each page has 8. 56 divided by 8 is 7. So on this, the tricky part was the equation. You guys knew what you were doing, but I think some of you got confused by this. First step was 109 minus 53. Then you would divide by 8. They gave it to you. But getting those numbers in was a little confusing for some of us, and that is understandable. So P equals 7, you put the 7 again. And last but not least, Peyton cuts a pipe into 2 pieces. One piece has a length of 12 feet. The other piece is 5 feet shorter. How long was the pipe Peyton cut? You might think this is a one-step problem, but it's not. They're trying to trick you. The first step is that he has one piece that is 12 feet. The other piece is 5 feet shorter. What's 5 feet shorter? Subtraction, so it's going to be 7. So this piece is 12, this is 7. How long was it? I have to add those to get 19. It was 19 feet. First, you had to figure out what the length of the second piece was. So here I would have said, this is going to be 12 minus the 5. That's my first step because it's in parentheses. And then it's the 7 plus that. Again, that's tricky. The format is tricky. Those parentheses are telling you what you do first. Serne, And then you put 19 here and 19 here. Did you have a question? Your hand is up. A pencil? Right in there. Mrs. Harrison will get it. Okay, so if you did not score, some of you are like, I didn't get 80%. I didn't get 80%, I'm sad. Don't be sad, just be challenged to do better next time. It's okay. The highest score I got was 70%. I would say the majority of us got about 50%. So I just am telling you that I want you to feel okay about it. That was hard. You guys are smart. You can do this and we'll keep working on it. Okay. So I just wanted to take the time to review it, but we'll move on and we'll keep putting problems like this in our review. Sound good?
Yes.
I just felt like I should address it because on Friday, some of you seemed a little upset about it. Like, oh, this is because now you know how to check surname. You know how to check your score, and you guys know 80% is good. And it's okay that you know that. I just don't want it to upset you all the time. Don't be upset, okay? Just learn from it and do your best. If you're doing your best, that's what counts. And you know if you are or not, and you guys are. All right, so let's go to our new unit. I'm pretty excited. Today we are going to talk about shapes. So our learning target is understand the relationship, because there is a relationship, just like in multiplication and division, between angles, triangles, and polygons. So we are going to probably have to do this for 2 days, and that's okay. And we are going to do this because there are math problems in the real world that involve triangles. And I think of people who build houses, or I think of people who design houses, interior designers. I think HGTV. What do you guys think of real life using shapes? What are you thinking, Sunny? Your dad's a contractor. So that's one example. Haley, is your hand up? No? Okay. I see August. What do you think of when you think of jobs and real life that involve shapes? Oh my goodness, that's so cool. What a cool job. August's dad is a carpenter at the zoo. So he probably deals with these types of angles, right? I see Lennox. Did you have an idea? One more time? A drawer, an architect, maybe someone who designs things and draws, or an artist, like an artist. Excellent. Yeah, Finn. Oh, great. So we have Finn's brother has his own business where he designs decks and houses and builds things. So I see lots of hands up. So we're going to stop there. I think you all get the idea that this is an important life skill. You'll be able to compare and model angles. That's why I wanted you to get those 2 pencils. You're going to describe triangles by the number of sides of equal lengths and by the types of angles. Hopefully we'll get to the building polygons as well, with the same size and shape of things. So let's move on. We did that. So we have tons of vocabulary. I've been working on a GIM kit for us for the end of the week to play. So be thinking about this vocabulary. We'll do, I have a fun day planned for Thursday with geometry, with these vocabularies, words and shapes. An angle, that's what we're going to be talking about today. Anybody have schema about angles? What do you know about them?
An angle is like where there's a square and there's 4 sides that are exactly the same. You can make tiny squares on them, and you're looking at different angles of it. And then on a triangle, you can like look at the different sides and see like how they're different or the same.
Okay, so Lila Maris is saying that there's angles within shapes is kind of what I heard from that. And they're different. Some are like square corners, some triangles might be smaller. All right. So let's go back. Somehow that did that one, I admitted. An angle is a figure formed by 2 rays. And a ray is just like part of a line, it has an endpoint, but then it has an arrow and it just keeps going in one direction. Or two line segments, and a line segment is part of a line that has endpoints at each end that meet at an endpoint. So I just gave away the next one. So a ray kind of looks like this. Oh, I know what I gotta do. It's like an arrow. How many of you have ever seen an arrow? If you've ever shot a bow and arrow or shot an arrow from a bow, you don't shoot your bow, I guess. Right? You have an endpoint. There's a ray, and I think I need to align. A part of a line that has one endpoint right here, here's your endpoint, and goes on forever in one direction, right? Yeah, it's not a line. Okay. It's gonna look weird no matter what I do. So line segment is similar to a ray, except for instead of an arrow on one end, it actually has two, oh, it's not looking good, endpoints. Sorry, it doesn't look good with my smartboard, but I'm trying. So this is a line segment, this is a ray, they're different. Next, you're gonna learn about a right angle. These are the most common angles in our classroom I have found because I was looking for examples. A right angle has 90 degrees. Now degrees is just another unit, like centimeters, inches. It's not the degrees like right now I'm really hot. Like it feels like it's 90 degrees because I really am hot. But that's not what it is. It's the degrees measure the angle, right? In between. You probably have never heard that. You're going to hear about it throughout your math career from now on. So right angles form a square corner. You're going to make a right angle in a minute. Acute angles are smaller than 90 degrees. So if a right angle looks like this, or looks like a square corner, it's going to be less than that. And obtuse is going to be greater than 90 degrees. And you'll know what I mean here in just a second. And then we're going to look for some angles. We're going to make some angles with our straws. And okay, I think I am going to skip the next section because I don't know that I'll get to it. So let's watch the angle song and hopefully we'll build our schema. Oh, I have to be in present mode, I have heard. So let me go back. Exit. Mrs. Harrison taught me that. She said it won't work unless you're in present mode. Well, watch this on, okay. Oh, let's watch it on, who knows? That's weird. It always has worked before.
Between 0 and 90, an angle is acute. This angle's long, skinny, and kind of cute. It looks like a V or the top of a Y, or the angles that you see eating pizza or pie. Angles are measured in degrees, and here's how to remember them with ease. See, when an angle measures 90, we call it right. You can tell this angle just by sight. It looks like an L or the corner of a square. You're looking at it when you're walking up the stairs. Angles are measured in degrees, and here's how to remember them with ease. From 90 to 180, an angle is obtuse. This angle's kind of fat, it's got a big caboose. Like the hands on a clock when it's 1:45, or the antlers on the head of a full-grown moose. Angles are measured in degrees, and here's how to remember them with ease. To measure an angle, degrees with a protractor. Place the vertex at the hole in the center. 9 to 1, bring it 0 on the protractor.
That's weird. I had it. Maybe it's on the desk. I had it on your Bobcat one. You sure it's not under it?
It's okay. I wrote down everybody's name, so when I find it, I can.
So I had
Here's how to remember them with ease.
I do, I put it there. Look, I'm losing my mind. All right, guys, so let's see. That's 6.1. Let's go back. Here we go. All right, so we're gonna make angles with our straws or pencils. So some of you at home are going to use your pencils to make angles. So I'm gonna stop sharing so you can see what I'm doing. Hopefully you'll get to see me okay. Can you guys see me pretty good? Get your straws or pencils. If you are here in person, you'll put one end of your twist tie in one end of your straws and then put it in the other end. So you're gonna make an end point, really, so that you can bend it. I want you to make a right angle, 90 degrees. And remember, a right angle is straight up and down. It's perpendicular is what that means. And makes a square corner. Just like on our Zoom, you guys see all the right angles and the rectangles there where our faces are? So what is this called, everybody? Oh, I like that. I heard 90-degree angle. I heard right angle. This is a right angle. Now, here's how I remember acute. I think it's cute. Have you ever seen little kids are cute? Puppies are cute. Small things are what? Cute. So when you think of the angle being smaller, make your angle smaller with your pencils. You can use two pencils to do it, right? You can use your two pencils, make them join, make an acute angle. Remember, it's smaller than 90 degrees. So it could be 45 degrees. It could be 20 degrees. It could be 10 degrees. It could be 80 degrees. It has to be less than 90 because once you hit 90, it's now a right angle. But all of these are called acute. Say it with me. Acute. Acute is acute angle. Now, go back to 90. Go back to your 90-degree angle or your right angle. Now we want to make an obtuse angle. Say that word with me. Obtuse. Obtuse is going to be greater than 90 degrees, but it's not going to go past 180 degrees. 180 is a line. 180 degrees. You can make 180 degrees if you want. That's a line. It's half of a circle, right? Because look, have you guys ever heard of doing a 180? I know Gabe has. I know a lot of these kids in here have done a 180. What about a 360? Yep. Okay, so when you jump and you try to do a 180 on your trampoline or on your bike or on skis, some of you guys are crazy. 360 would make a whole circle, 360 degrees, right? But an obtuse angle is not quite, it's just between 90 and 180, which is half of 360. Wow, we're getting into some hard math there. But the point is, you've got acute, small, obtuse is larger, and right in the middle, that square corner is a 90-degree angle. I want you now, make a right angle. This is the one that I said is the most common in our classroom. I want Gavin and Katie and Haley. Haley, you're in a hotel. I want you guys to look around your environment. And I want you to find at least one right angle. On your mark, get set, go. Find one right angle. You guys too. You see one? Not this one. In the room. Do you see any right angles? Okay, Reese, can you unmute? What right angle did you find?
I found my teacher's whiteboard.
Her teacher's whiteboard has a corner, right? These corners are square corners. So that's a right angle. How about you, Leo? Did you find a right angle? Where is it?
On a picture.
Oh, like a picture with a frame? Yeah,
Yes.
nice. Excellent, because that's probably a rectangle. Ben, do you have a right angle? Awesome. Do you guys see his ruler has a right angle on the corner there? Nicely done. All right, Haley, did you find one in your hotel?
Yeah, the TV.
The TV has a right angle. Awesome. Good thinking. Astria, I love that you're showing me your right angle. What is it? Do you want to unmute?
My MacBook.
Excellent. We all have that right in front of us. Jensen has got a great example. What is that, Jensen?
My map.
The map.
There's so
Okay,
many.
you guys share with the person closest to you, the right angle you found. Go.
Right here.
Right here. What about here? Here. Oh, Leo, check out this right angle. On your magnet you gave me. See all those right angles? Awesome. I have it right on my board where I can see it. All right, now make an acute angle with your straws or your pencils. Acute, remember that's less than 90 degrees. You want it to be cute. Make an acute angle. Now look around your environment. These are harder to find. I'm gonna give some hints to my kiddos here, look up. The rest of you, look around. Do you see an acute angle in your environment? Acute, less than 90 degrees. Acute angle. You're on an acute angle hunt with your eyes. All right. Haley Booker, where's your acute angle? Our ceiling has them. We have the lines. You guys might remember. I bet Reese and Katie can see those. If you look up, we have places where the panel, I don't know what you call those, roof tiles meet and an acute angle. Oh, wow, Reese, unmute. Look at what Reese has done. That's very clever.
I got my scissors.
You made it out of your scissors. They're very clever. I love that. Henry, were you able to find? You made it out of your pencils. Do you want to unmute and share? No? Okay, he was able to make it with his pencils. All right, everybody make an obtuse angle. Here we go. Go back to 90. Your right angle. Ready, guys? Now go obtuse. If you say obtuse, it helps. Obtuse. I'm having trouble finding obtuse angles in this classroom.
Obtuse.
Yeah, Marin, where did you find an obtuse? Oh, she made it out of a broken hair tie. Ellie, where did you find an obtuse? Oh, the corner of our ceiling has one that's greater, or is that? Oh, up there for sure. Yep. I see Lennox. Where do you see an obtuse? Hey, boys. Oh, you're working together? Okay. Sorry. Whisper. Where is it? On the ribbon up in here. It's like an obtuse angle. All right. Anyone at home? Jensen has an obtuse angle. Yes, Jensen.
It's my pillow.
Hey, your pillow has an obtuse. Are you sure it's not right angle? Looks a little bit like, oh, you're making it out of that. Okay, I see, I see. Haley has one.
On the wall and the ceiling.
Oh, it's
And
your
the walls. Over there.
awesome. Okay, Great job. Let's go ahead and put our straws to the side and our pencils to the side. You're gonna listen and learn, right? We're gonna go ahead and turn to our workbooks on page 298. We're gonna use our knowledge, girls. Can I have you here? You here? We're gonna use our knowledge of types of angles to describe triangles. So everyone's on page 298. So let's look at some of these triangles.
Triangle.
Yep, these triangles all are a little bit different. This is why we don't dress formal. So all of these triangles, if you look carefully, have something in the corner. Have something in the corner. What do you see, Lyric, in the corner of these triangles? There's a square. That is a symbol that mathematicians use. We're going to put these to the side now. Put the straws to the side, page 298. That is a symbol that they use to represent that the triangle has a right angle. Why do you think they chose a square, Josh, as the symbol to show a right angle? Boys, can I have you separate? I don't know how your desk got that.
Right angle is because a right angle is like sort of a square.
It's called a square corner. So that's why they chose that. All of these triangles, and we all know what a triangle is, right? Lucas, what does tri mean? Not quite two. How many sides does a triangle have?
3, like a tricycle.
Tricycle, right? Tripod. It represents the number 3. So tri meaning 3, angles. It has 3 angles. These angles are not right angles though, are they?
No.
Nope. All of these triangles only have 1 right angle. But not all triangles have right angles, do they?
No.
Look at the next 4 that are green. They all have angles, but there's none that are right angles. What kind of angles do you think they have, Henrik?
I think they have.
What kind of angles do these have? Are they acute, obtuse? They're not right. Which ones are they? Smaller than a right angle or larger?
I think they are a little longer.
Well, let's look. You know what is a good tool? If you take a piece of paper or an index card and you put it next to that angle to see if it's right, I can line it up and it is smaller than a right angle. You can line it up and you'll see that it's smaller than a right angle. So what are those called? A cube. Yeah, we actually don't call them a cuties, but that would be fun. They are cute, but we call them a cube. So yeah, all of these have angles that are smaller than a right angle. What about the orange triangles? What do you notice, Paxton, about the orange triangles and their angles? Okay, instead of long, can we use our vocabulary greater than 90 degrees maybe, which is obtuse. So these all have at least one angle that is larger than a right angle, and we call that obtuse. I don't think these math people think you can learn those words. Do you think you can?
No.
How many of you think you can learn obtuse? How many of you think you can learn acute? Yes, you can. Of course you can. So here's an obtuse angle. We have an obtuse. We have another obtuse and another obtuse. What are the other angles called? They're not larger, they're smaller. Elena, we said when we see puppies and babies, we think they're what? So these are all what kind of angles? Acute. So not all triangles are gonna have right angles. Now, we are gonna look at triangles K, L, and M to answer these questions. I'm gonna have you do that. Here are the questions you have to figure out. You can do this independently. It's that easy and you guys can do it. I know you can. Which triangle has one right angle? Don't say it out loud. You're gonna write the letter that's inside the middle of the triangle that has one right angle. Then for number 5, which triangle has 3 angles smaller than a right angle? That means they're all acute. And then number 6, which triangle has one angle larger than a right angle? Go ahead and put your answers down. You just have to write one letter. There's only going to be one letter for each. You're looking on the wrong page. Page 200, some of you are on the wrong page, 298. Finish that first, then you. I see some differing ideas. Show me if you need 1 minute or 0. At home, show me if you need 1 minute or 0 minutes to finish numbers 4, 5, and 6. Ben needs 5 minutes? Or do you have a question, Ben? 4, 5, 6.
I have a question.
What's your question, Jensen?
What are we supposed to write?
Just the letter K, L, or M.
Yeah, but there's 4 of
You
them.
just have to write the letter that goes with it. Okay, here we go. Which triangle has one right angle? If you said K, stand up. If you said L, stand up. If you said M, stand up. One right angle. All you had to do is look for the square, right? M is correct. You should have written M. And the reason being, everybody show me a right angle again. Show me a right angle. Cooper, show me a right angle. Show me a right angle. It's a square corner. Does K have a right angle?
No.
Does L have a right angle?
No.
Look, the only one that has a right angle, it has this square right there for you to see, is M. You should have said M. No, we're on number 4. Okay, number 5. Which triangle has 3 angles smaller than a right angle? If you said K, stand up. If you said L, stand up. Not on your chair, sir. If you said M, stand up. Okay, the problem is, if you said L, you missed that this one has an obtuse angle. You should have said K. If you said K, give yourself a pat on the back. You got it. All of these angles are smaller than a right angle. They're cuter. And number 6, which triangle has one angle larger than a right angle? What is it, Madison? L. Here it is. This one is obtuse. It's larger. These are pretty small. So it has 2 acute and 1 obtuse. All right. Moving along. So how are we feeling so far about angles? We're going to be using those to describe our shapes. How are we feeling so far about right angles, acute angles, and obtuse? Let's do it again. Some thumbs down. Okay, well, let's do it again. Ready? Everyone take your hands this time, not your straws. Put your wrists together. We're going to put our wrists together. Some people are still thinking they don't get the angles. Okay, make a right angle, 90 degrees. Everybody make a 90-degree angle. Let's see it, let's see it. Not, this is not a 90-degree angle. Look at me, Robert, don't do this. Make a right angle. Thank you. Make it straight up and down, perpendicular. Okay, now, acute. Acute. Come on, Gavin, want to see your acutes. Come on, Abby, acute. 90. Make a right angle. Obtuse. Acute. Right angle. Obtuse. Acute. 90 degrees. Acute. 90 degrees. Obtuse. Acute. Obtuse. Acute. Obtuse. Acute. Obtuse. Acute. 90. All right. They're angles. That's two rays or line segments that meet, right, to form like a corner, a space in between those. Let's hopefully by the end of this unit, you'll feel better about it. We'll keep working on it. All right, next part of our lesson is about quadrilaterals. Does anybody have schema on what a quadrilateral is? Yes, Miss Elena. She thinks it's something with 8 sides. I'm going to tell you not 8, but it does have to do with the number. You're on the right track, my dear. Josh, what schema do you have?
It has 6 sides.
Not 6. I want to give you a hint. There's a ton of you in here that ride these quads, right?
Yeah.
You tell me when you come in on Mondays how much fun you've had. I rode my quad. How many wheels does your quad have? Not your bicycle, your quad. Lucas, you 4 sides. Maybe that will help us with what a quadrilateral is. Okay, let's see if this one wants to work. Nope. Okay, let's watch it on YouTube. That's interesting. That's okay.
CoverUp.com, school's lead digital library of math videos. Now available ad-free and child-safe at CoverUp.com. In support of distance learning, we're offering. Parallelograms have 2 sets of parallel lines. Trapezoids only have 1 set at a time. A rectangle has 4 right angles. A rhombus has 4 sides that are equal. Squares have 4 equal sides and 4 right angles. Quadrilaterals have 4 sides and 4 angles. Parallelograms, rhombus, trapezoids, squares and rectangles. If you add the angles inside each of these, there will be 360 degrees. Parallelograms have 2 sets of parallel lines. Trapezoids only have 1 set at a time. A rectangle has 4 right angles. A rhombus has 4 sides that are equal. Squares have 4 equal sides and 4 right angles. Quadrilaterals have 4 sides and 4 angles. Parallelograms, rhombuses, trapezoids, squares and rectangles. If you add the angles inside each of these, there will be 360 degrees.
Okay. So why do you think, let's get out of that. Why do you think they named parallelogram, rectangle, square? Why was that something that they kept repeating? Why do you think?
Because they're all
Rhombus.
quadrilaterals.
All of those shapes have something in common. They all have 4 sides. They're called quadrilaterals. They could be a trapezoid, a parallelogram, a square, a rhombus, a rectangle. All right, so we are going to cut out. I'm not sure what's going on there. Okay, we're gonna just start, we're gonna look at page 301A. You have it in your math workbook, and you can actually rip out the page, or Mrs. Harrison and I can help you rip out the page if you're at home. You could ask a parent if you're not sure how to rip out page 301A, because we're gonna just start today with the two blue triangles. We're gonna cut out those two triangles with one angle larger than a right angle, called an obtuse angle. So I want you to take out page 301A and cut out your two blue triangles. If you would like help ripping out your page, you could use your scissors and cut out the page, that's fine. But just don't cut out the green ones or the red ones yet. Leave those, just cut out, that's okay. Just cut out your two blue, all right? I'm gonna give you a minute to do that. That is fine, no worries. Your scissors may set up the other stuff. Who needed scissors in my room? Everybody good? Do you still need scissors? I passed some out earlier. Anybody else need them?
Yeah.
You found yours, that's exciting. All right, next thing I want you to do, once you have cut out your triangles, you're going to use those to try to make a quadrilateral. I will model that as soon as I cut mine out. Remember, you want a four-sided figure. You cannot overlap. And they has to be four sides. So let me stop sharing and we'll do this on the document camera. Oh, I guess I want to share again, don't I? Silly me. I do want to share, but I want to do it with my document camera. And I want to see how many quadrilaterals you can make. Okay?
No, it's not there.
How many different quadrilaterals can you make using these triangles? And I'm going to try, I want you to move them around. Don't overlap them. You can't do that because it wouldn't be a quadrilateral. I want to see, do you guys have any ideas how I could make a quadrilateral out of that? Serne, will you come up and do mine real quick? Serne thinks she has an idea. All right, give me a thumbs up if you were able to make that quadrilateral. Let's make sure Serne's right. Let's count the sides. 1, 2, 3, 4. That looks like a parallelogram to me. So she did it. Anybody else have another one? Max Fox. Come on down. Show me what you mean. Oh, you can flip them too. You can use the white side as well. You show me on yours. He's going to show it on his. Oh, same. You just turned it, or no, you did something different, did you? Oh, no, you just turned it. Okay, so same one. It's just he moved it. You can take your triangles back. Paxton, do you want to bring your triangles up? So we got lots of parallelograms, but I'm telling you, you can make more that are quadrilaterals. You'll be surprised. Oh, awesome. Look at this, you guys. This is that a quadrilateral? Let's count. 1, 2, 3, 4. It works. That is a quadrilateral. It has 4 sides. Quadrilateral. Boy, that's a lot of syllables. Let's count them. Quadrilateral. 5 syllables. Cooper, you can bring yours up. Good job. And then Jensen, I see you. We'll let you do yours. So we had this one. We've had this quadrilateral. Let's see another one. So he flipped one of his, and his looks like a kite, doesn't it? You could make a kite. Let's count the sides. 1, count with me. 1, 2, 3, 4. Is it a quadrilateral? Sure. Josh, come on up. That wrong Josh. Sorry. We'll get you next. Woo, that one's awesome. Let's count. 1, 2, let's see. 1, 2, 3, 4, 5. Close. Let's try this. Because it's the same idea as what you have, but if we flip it, let's flip it.
Yeah.
There, now.
I was gonna think
You think? Would that work? Count them, Josh. How many we got?
1,
1.
2, 3, 4.
What do you guys think? I love that. Good job. Good thinking, bud. All right, the other Josh, do you want to give it a whirl? What do you got? Boy, there's like 6 different ways. I think we're getting them. Yeah. Looks like an airplane, doesn't it? Let's count them. Count the sides. Make sure.
1, 2, 3, 4.
If you count the sides and you get more than 4, it's probably not a quadrilateral. Haley Booker, what do you got? I think we might have gotten most of them. One, let's see. 1, 2, 3, 4, 5. Not quite quadrilateral, but I think what you could do, let's see, that's similar, is this. 1, 2, 3, 4.
Yeah.
Or did we do it this way? I think we might have got them all, you guys.
Yeah.
All right, good job. Let's cut out our green ones. Go ahead and cut out your green triangles. Just cut out your green. Now these triangles have all acute angles. They have 3 angles smaller than a right angle, whereas the blue had 1 obtuse. All right, see what you can do with the green. How many quadrilaterals can you make? And I'm going to try not to be tempted to make them. I want to. You're doing the same thing, but this time with triangles that have acute angles. Charlie, you go after her. All right, Sunny's going to show you a quadrilateral. How many give me a thumbs up if you got that one? Count the sides, Sunny, make sure.
1, 2, 3, 4.
Yep, thumbs up. Okay, don't forget your triangles. All right, Charlie, what did you find? Gotta push it up. Nice. Count your sides. Excellent. Good one. Any others? Lucas. Oh, that's a cool one. Do you guys see it? You got to push it up. Count your sides. 1. All right. Looking good. All right, Jensen. Yeah, don't let them overlap.
How am I gonna show them?
You can push your screen down, like your top down, and put it on your keyboard. Yeah, we can see it. That works. Or you could hold them up how you had it. You had like a diamond. All right. Go ahead, Bird. Come on up. Yep, I think we did that one. That one works. Does it have 4 sides? Very nice. All right. All right, let's have Madison. I don't think you've been up yet. And then we'll try our reds. What do you got for us? Ooh, that's a good one. Count your sides.
1, 2, 3, 4.
Very nice. All right. You could have also flipped to the white side and gotten that one. Yeah. And then, of course, made it look like August. Like so. All right. Let's try with our red triangles. Go ahead and count. Cut out your reds and start building. Now, the red ones actually have a right angle. One right angle. One right angle. Remember, it's a square corner. A right angle measures 90 degrees. What can we make? Come on, Cooper, bring yours up. Let's see what you got to make quadrilaterals. Thumbs up if you agree with Cooper. Count your sides. Count your sides. He says there's 4. I agree. Okay, another one. Who hasn't been up yet? Lila. And then Ren hasn't? I mean, you've been up today.
It was kind of like a
Yep,
kite.
that works. Count your sides. Looks like a kite.
1, 2, 3, 4.
Nice. All right, Marin. Oh, put it where you can see it and count your sides.
1, 2, 3, 4.
Excellent day. And Josh? Okay, count yours. He says this one, but I'm going to make him count his sides.
1, 2, 3, 4.
5, 6.
Oh,
And they're not sharing a side. That one does not work. Not quite, but you could do something like this. Let's see.
like this, Mrs. Robert?
Like a triangle like that. That works. All right, kiddos, you may put those aside for now. Here's how we are going to end today. Now that I see how far we got, I can actually skip forward. just put those to the side. We're gonna go past some of this. We'll do this tomorrow. But we are gonna get our exit ticket in today. If you are remote, it's on Google Classroom. You will have an exit ticket to make sure you turn in to me. Here's what I'd like you to answer. Explain the difference between a right angle, an acute angle, and an obtuse angle. What's the difference between them, or tell me what they are? Now remember, this is in your Google Classroom. I'm going to show you where. And if you are in person, I'm going to pass out your exit ticket. You will need your pencil.
What do we do with our triangles?
You can recycle your triangles. I don't know. So here you are. I'm going to ask everybody here to be quiet so the kids at home can hear me. Thank you for whole body listening. Today, you're in lesson 6.1 under math. It says exit ticket for lesson 6.1. You will go to it just like you have in the past, and it will say explain the difference between a right angle, an acute angle, and an obtuse angle. If you are in person, you can draw an example. I would love for you to draw and label one of each. Draw and label one of each. All right. So I'm going to go back to that exit ticket. And for us, it's exit ticket number 7. Once you have submitted, remote learners, then we are going to do a quick check on how we're doing, and you have Think Central 6.1. Let me just put this in present mode.
Miss Aubin, 6.1. Mrs. Aubin,
Yes,
I
Amy.
think Central there's no 6.1.
You went muted. I didn't hear you. You muted.
No 6.1 on Think Central.
Okay, thank you. I'll put it on for you.
Okay, thanks.
You're welcome. I'm gonna stop recording real quick. He told me, yeah, good. That's fine. Okay. There should be some on my desk on the right. On the right in my, on the, those like spare on the bottom. Yes, Jensen?